we basically did the equivalent of, like, since I can't actually show you the actual radiator, an academic exercise and like what are the sort of design steps and thinking and how I would basically make a radiator better. And so starting all the way over here, this is kind of, and I might even do it in plan view. Standard radiator, we got out like 3 different pipes or three different U-bins with another series of 1, 2, 3, 4 straight pipes, and then 51 different surfaces or like pieces that you would have to cut and then weld onto all of this object. And the only reason these things are here is because it's really, like, outside of that radiator shape, is because it's really hard to cut and weld onto a crazy surface, or like a crazy, if you were to slide this down in here, for instance, it'd be really hard to cut those fins to match that specifically and have it work really well. So a lot of times, I'm not saying they're lazy, but they just sort of drag stuff out and on top. It makes a lot more sense. It's so much easier to machine. Like I would do the same thing. But then with 3D printing, it was like, well, immediately, right away, I can just put those the U-bins inside of the object right away. It's no harder to do that. And so this has already increased the surface area, or like the surface contact. If this is, say, a radiator and it's hot water running through here, I've already increased the surface area contact with the fins automatically, and I've reduced the overall part volume, the overall bounding box of the part, by not having these U-bins on the outside, and there's no welds or soldering or anything like that. That's one straight pipe all the way through the whole object. But maybe the goal is, like, I really want to actually add more surface area to this part. And so I could either, like, analyze the surface area of that pipe and be like, what's the most amount of surface area I can flow water through? Like, what's the best shape for it? In this case, I will say I was just sort of lazy, and I made 3 pipes that are, they're thinner in cross-section, but they are not just circles. They're kind of distorted oval-shaped pipes running through there. And so, for instance, the surface area of just this pipe, or even, there's a bunch of them. I think there's a curve in here somewhere. There's my curve. Where'd it go? Curve. Pipe 4. So this is my original pipe. If I type in area, I have 5,000 cubic millimeters. If I type in the surface area for all of these 3, I now have 12,000 cubic millimeters. I've immediately increased the surface area of it without actually really doing anything to the overall geometry. And the volume is, I think if I did this right, still the same, approximately. We've just got a slightly higher surface area. It might be higher volume too. And so then I was like, well, let me zoom into a bigger screen. I was like, well, now there's a lot of, like, unused space in here and here that can't be that efficient, right? Like, there's not, if I can pass air in between those gaps, that's a giant area for me to pass air through. Like, I could totally fill that with more, like, basically more surface area and more areas for water. So I increased the number of pipes. And they all taper still, but I now have a really large surface area of pipes, all still, like, in the intention of just, like, basically just getting heat off of the part as fast as possible. Now, is this shape really the best shape to be running? Like, do we know that a funny U shape is the best possible way to, like, burn heat off of, or, like, to basically get rid of heat on an object? Would something maybe like a sea fan, maybe that's a better shape, or maybe like a leaf is a better way, or some sort of, like, anything. You just kind of have to not start looking around, but you could even use like some sort of heat analysis software. Like in here, that heat button probably will generate, I've never clicked on it before, but will probably generate an interesting sort of shape that'll be good at whatever the parameters you are. It's more than just a one button click, or I would do it for you guys. And then I moved on to, like, so what happens with the fins? Like, let's start refining just the louvers. And so I added an extra set. So instead of having, sorry, let me go real big here. Instead of having, like, pretty standardized, everyone's the same, stamped out of a block of steel or extruded off a line, like everyone's identical, like, let's make, oops, not far enough down the line yet. Let's make 2 different kinds. And so we have, like, 2 different height parts there for the air to pass. I was envisioning the air passing from the top and going through it. And so it would pass in and get a little bit more compressed as it goes through there. And then really, like, is a flat sheet the highest surface area possible thing there? No, like, that could be full of holes, just subtle holes, or maybe a surface texture. That's just a very, like, that hexagon surface texture on there, just to increase the surface area yet again. And then even really, and you can keep going. Like you can just like, what's the best possible, just starting from a radiator. And then I sadly forgot to save it, but at a certain point I was like, what's the, do I have a bottom one down there? Yeah. So like maybe tubes aren't the best surface area at all. Maybe I need to actually run a, did someone have a question? So like I can totally go in here and very quickly, oops, wrong surface. Set one surface, that surface, set another surface, that surface, and then if I go get a, oh no, if I basically conform some sort of topology to those surfaces, preset cell, tesseract, topo, surface. And just for the sake of ease, I'm going to hide these things so you can see what I'm doing. And I have to increase the 30 and 30. So now I've got this like crazy structure running through here that I could maybe flow water through. It's still just curves. And so maybe I make it too tall. And then like maybe that funny box structure isn't the best possible structure to flow stuff through, so maybe that's better, or that's better, or that's better, or this is better. And then like after some testing and some analysis, I've come to the conclusion that like maybe I like this kind of structure for having fluid to flow through. And so if I really quickly just basically mesh it all with two millimeter radius. It might take a second because that's a lot of pipes. But that was a really quick way. And oops, yeah, it blew up. 0.5. Sometimes that happens. But so like that was, and we haven't even really started to refine it at all. I'm just in sort of like, yeah, there we go. If I like bake this. So this was one that it was sort of like, I knew a lot of Grasshopper. I didn't know a lot of Grasshopper. This was both a combination of like talking to people in the field and basically a background in these things. Like if I had been a SolidWorks person, this would probably be somewhat similar, but leveraging the parametrics of SolidWorks rather than the parametrics of Grasshopper. I originally started in architecture, and so this was actually leveraging a lot of like architectural concepts. Like once you hollow a part, for instance, it's now closer to a building than it is like a standard, like an industrial design part. Like once I make a hollow block, now I have to think of how I support the top of the block. Now you've got columns in it, and now you're basically, it's a small building. But like, and same with if I have fluids flowing through like a hollow object like this, it's same with the doors on this building. And then maybe this room is actually a bioreactor. The scale is just different. And so that was kind of where I originally started in, but the resources are sort of scattered throughout a lot of different industries online, because this industry is sort of, I don't want to say 3D printing is so new, but the sort of, since the consumer boom a couple of years ago, it kind of like became a new industry all of a sudden. And so there's a lot more resources coming out all the time. I definitely follow a combination of like architects, industrial designers, artists, and engineers that all have different sort of specialties that I'm like, some artist will figure out how to make some random shape, but he made a bone structure doing it, and it's just a blob. But however he did it is totally like applicable to actually making like an actual bone structure inside of objects rather than just a lattice structure. Maybe you get the incredible complex gradient, like currently this is compared to like the bone in my femur, the complexity in that bone is like light years ahead of anything I can make in Rhino right now. But this one artist figured out how to do it. And so I was like, how did you do that? And then we took that exact same technique that he did and just applied it to an engineering object. And so there's a lot of sort of cross-pollination between different industries. Like the eggshell molding came from originally like casting stuff in ceramics, and it was like, hey, I can recreate that process with a different material on a different machine, but it would never have known if it hadn't been done in a different industry before. And so, but I mean, a lot of I will say, almost everything I know that wasn't learned through experience, it was learned off of YouTube. And so there was definitely, I don't know if that's a good or bad thing, but like in school, when I would ask questions to my professors, they would be like, there's great resources online. And after 4 years of hearing that, I just decided to actually see. And there are great resources online, and you can really do most stuff from like YouTube or like digging through some blogs. There's so much just free information out there, and like just even like free scripts people have written and stuff like that that they just give out.